Hey, so in today's video I wanted to talk about integration. And when I think about integration, what I'm thinking about is the answer to the question, what function do I differentiate dx to get of some f of x to get x squared? And to answer this question, what function f of x do I differentiate to get x squared? To answer this question, I'm going to differentiate. I'm going to integrate. So the way I'm integrating, if you imagine, I write this integral sign, and then I'm simply going to put x squared in here, and then customarily we just write dx beside it, equals to f of x. So the integral of this expression will tell me what function do I differentiate to get x squared. And there's a number of tricks that we'll probably learn as we go along. And for instance, for functions that look like this, if I want to get the integral of x squared dx, what I'm going to use is this approach where, remember when you differentiate, we take one away. So going the opposite way, I'm going to add 1. So that's going to be 2 plus 1. And if you recall, when I differentiate, the original index number, the original power, would appear in front of x squared. However, I don't see any power numbers. And in this case, so what I need to do, I actually need to divide below by this 2 plus 1. And last but not least, I have to remember that any constants that are present in this function after differentiation are going to disappear. So I have to add this constant of integration, and if I finish the calculation, I'm going to get that x cubed over 3 plus c equals to f of x. Now let's see what happens if I dx, if I differentiate x cubed over 3. If I differentiate this function, so that will be equal to 3x squared over 3 and plus 0, because then the derivative of a constant is always 0, and that will simply be equal to x squared. And that's exactly where I started. So integration is a process of finding answer to a question, what do I need to differentiate to get a given function? So there are a couple of standard so there are a number of standard integrals, and these are the integrals that we can use when integrating complex functions. So we have a x to the power of n. Integral of this function is going to be equal to a x to n plus 1, all that divided by n plus 1, and we have to remember about the constant of integration c. If I'm integrating cos of x, let's just include this coefficient a, integral of this, that's going to be equal to 1 over a sine ax plus c. In a similar fashion, integral of sine ax is going to be equal to minus 1 over a cos ax and plus c. So you can see that it's kind of similar. It's kind of similar in its nature to what we've been looking at previously. Two more that I want to take a look at is this one here. So if we're integrating integral of a, maybe there isn't really a need for this because constants taken out from integrations. So let's say e to the power of ax and dx, that's going to turn into, and dx can be there or doesn't have to be there, it's just an addition really. E over ax dx equals to equals to 1 over a e to ax and plus c. Note that the index number for the exponent doesn't change, And last but not least, we need to take a look at an integral of 1 over x. Note that this is the only the only occasion where we're going to take a look at a power of x, and we won't use this approach. If you remember, this expression is the same as x to minus 1. So n's so n does not equal to 1. If n doesn't equal to 1, we're going to use this approach. If n is equal to 1, and that means that we're integrating 1 over x dx, what we need to remember is that this is actually going to turn into natural log of x and then plus c. Okay, so these are the functions that we need to, the integrals that we need to remember. And let's take a look at a couple of examples of integration. So an integral of a function, let's open up at the bracket, 4 plus 3 over 7x and minus 6x squared, all that dx. So I'm going to do an integration of each of those functions separately. So that will turn into 4x, and then 3 over 7x will be plus 3 over 7, just for sake of reminding ourselves what we're doing is 3 over 7x 1 plus 1 all over 1 plus 1. Note x to the power of 1, so I have to add 1 and then divide by the resulting number, and then minus 6x to the power of 2 plus 1 divided by 2 plus 1. So if I simplify this a little bit further, I'm going to get, obviously plus c. So I'm going to get 4x plus 3 over 14x squared and minus 6 over 2 is 6 over 3 actually, minus 2x cube and then plus c. So that would be the resulting integral. Looking at a different example, let's take a look at integral of 1 plus theta, all that in bracket and squared, all that divided by root theta dx. So the simplest way to integrate this type of expression is to get rid of the bracket above the line. So that will turn into an integral of 1 plus 2 theta plus theta squared, and all that divided by root theta the theta. And now I can simplify it by separating it into partial fractions, so fractions of the same denominator, root theta. So that will turn into integral of 1 over theta, let's open the bracket, 1 over root theta rather, plus 2 theta over root theta, and plus theta squared over root theta, and all that d theta obviously. I can simplify it a little bit further by writing it all as exponents, as power numbers. So that would be theta to power of minus half, and then plus 2 theta over theta is root theta to root theta, which will actually be, it can be written out as 2 theta to the power of half. And then finally root theta is theta to the power of minus 2, and whenever we divide we can subtract the exponents, so that will turn into plus theta to power 3 over 2. All that integral of this expression and d theta in the end. So now I can do the integral, and again above the line I'm going to have theta minus a half plus 1 over minus a half and plus 1. For the second term, 2 theta to the power of half, so that would be 2 theta to half plus 1 all over half plus 1. And then for the last one we're doing exactly the same thing, plus theta 3 over 2 plus 1, all that divided by 3 over 2 plus 1, following our approach to integration, and plus the constant of integration. So after simplifying this, I'm going to get for the first term, above the line, minus half plus 1 is a half, and half divided by a half is 2, so that would be 2 theta to the power of half. Then for the second term, I have 2 theta to the power of 3 over 2, all that divided by 3 over 2. So 2's will cancel, and I'm going to get 3 plus 3 theta to the power of 3 over 2. And then last but not least, we have plus 2/3 theta. Am I right in third? No, plus 3/3, that would be 5/3, so 5 over 2. 2/5 rather, 2/5. Let me do it in the line below. So that will be 2/5 of theta to the power of 3 over 2 plus 1, which is 5 over 2. Theta to 5 over 2 and plus constant of integration. Let's take a look at one example with exponents. So we have an integral of 5 e to the power of 3x dx. So remembering from integration that the resulting integral is 1 over a e to ax. So we're going to get 5 multiplied by 1 over 3 e to 3x, and obviously plus constant of integration c. Simplifying it, we're going to get 5 over 3 e to the power of 3x and plus c, and that's the resulting integral. And second last example I want to go over is an example of integration with natural log. So let's take a look at this example, integral of 3 over 5x dx, and I can rewrite it as an integral of 3 over 5 multiplied by 1 over x dx. So I can take actually this 3 over 5 out of the integration because it can be used as a factor, so I'm only integrating 1 over x, and if I'm only integrating 1 over x, the result is ln x, so the resulting function from this integration is going to be equal to 3 over 5 natural log of x, and obviously plus the constant of integration. And last, let's take a look at integration of trigonometric function. So we have 4 cos of 3x and dx. And when I'm integrating that, I'm remembering that an integral of cos of x is, if I recall it correctly, sine of x. Let's go take a look back. Cos of x, 1 over a sine ax. So to get to the end of this integration, I'm going to get 4 multiplied by 1 over the coefficient in front of the variable is equal to 3. 4 times 1 over 3, and then we're turning cos into sine. Sine 3x plus c, and simplifying that equals to 4 over 3 sine 3x plus 3. So that's the kind of examples that we're going to be dealing with for integration of simple functions. We need to remember to use the cheat sheet, which I'm going to have uploaded to the resources. And yeah, that's it for this video. Thank you for watching, and see you next time.